Welcome back. Thanks for joining me again as we go through this lesson on Application Load Balancer Basics. We're going to go through ELB definitions. We'll go through a conceptual overview. We'll talk about how data flow works in the VPC. We'll look at benefits and use cases, and we'll talk about pricing. So let's get started with our definition. So what is an elastic load balancer? Our essentials definition is that an ELB evenly distributes traffic between EC2 instances that are associated with it. So essentially, we have multiple EC2 instances, and an elastic load balancer looks at the incoming traffic and distributes it evenly between each of those EC2 instances. Our AWS definition is that a load balancer distributes incoming application traffic across multiple EC2 instances in multiple availability zones. This increases the fault tolerance of your applications. Elastic load balancing detects unhealthy instances and routes traffic only to healthy instances. So as we use elastic load balancing, our EC2 instances have to be distributed across multiple availability zones. And our elastic load balancer monitors the instances and determines if they are healthy or unhealthy. If they determine that an instance is in an unhealthy state, then it will no longer route traffic to that instance. So let's go ahead and take a look a little more at how an elastic load balancer works. When we set up an elastic load balancer, the address assigned to the elastic load balancer is what we give to our end users, so that when they try to connect to the servers, they're actually connecting through the elastic load balancer. The elastic load balancer then evenly distributes the traffic to the EC2 instances. The instances have to be in different availability zones. So all requests that come in that are destined for our web server will go through the elastic load balancer and again be balanced between our EC2 instances. So when we think about that diagram, one of the things that you did not see on there was our route table. It's important to understand where the route table fits into this picture. Because we have a limited amount of space, we've left the route table out of some diagrams, but the route table is still always there. So I wanted to take a moment to show you a diagram that actually has the route table in it so that you can see where it fits into the flow with the elastic load balancer. So when traffic is received from the internet, the elastic load balancer then determines where to send that traffic. So if you remember, our route table controls the path that data takes into and out of our subnets and how we get out to the internet. So the elastic load balancer uses the route table so that it understands how to send traffic out to the internet and how to send traffic to our EC2 instances. Our elastic load balancer directs the traffic to the appropriate EC2 instance. It passes through the route table, through the network access control list, into the subnet, through the security group, until it reaches our EC2 instance. When the traffic is returned, it's returned from the web server back through the security group, through the network access control list. The route table tells the traffic where to go, and then it goes back through our elastic load balancer. So again, that gives you a quick overview of how the traffic actually moves within our VPC between our elastic load balancer and our EC2 instances. Now, something to keep in mind is that in order for it to load balance this traffic, the configuration on these two servers needs to be identical. Otherwise, our users will get different results when they connect to server 1 versus when they connect to server 2. So let's take a look at conceptually how an elastic load balancer works. So we have a group of users that want to access our website. When those users go to access the site, the elastic load balancer then determines where to send that traffic. The goal of the elastic load balancer is to ensure that data is evenly distributed between our two web servers. So by evenly distributing this traffic, it prevents any one of these servers from potentially overloading and crashing as a result of being too heavily loaded with traffic. So again, our elastic load balancer is responsible for ensuring that traffic is evenly load balanced between our two web servers. So when we think about pricing, there is no free tier usage available for elastic load balancers. You're charged for every hour or partial hour that the load balancer is running. And you're also charged for every gig of data that's transferred through the load balancer as well. As with other AWS services, prices can vary depending upon what region the services are used in. And before any major usage of Elastic Load Balancers, you should review AWS's current pricing model to make sure you understand how much you'll be required to pay when using Elastic Load Balancers. So let's go ahead and summarize. So again, an Elastic Load Balancer evenly distributes traffic between EC2 instances that are associated with it. It increases fault tolerance of your applications by ensuring that there are multiple EC2 instances in multiple availability zones. It also detects unhealthy instances and routes traffic only to instances that are determined as healthy. So that concludes our ELB Basics. Thanks for watching. I'll see you in the next video.